So just to repeat it for anybody who might have just joined a little late or did not follow the whole argument, Galileo's inclined plane experiment with the bells placed at regular intervals would have told him that the object, when it rolls down, does cover greater and greater distances as it rolls. So, by readjusting the bells in such a way that the distance between the bells keep increasing, he can find out if he can make the bells ring at regular intervals, because the interval between the first two bells would be lesser than the interval between the second and the third bell. If the ball rolls down faster over here, then by minutely adjusting the distances between the bells, he could make the bells ring at regular intervals. By that, he would be able to work out in some way how the rate at which the speed increases, whether it is uniform or not. Okay, so such things would have been possible for him to investigate, something that was not possible to do earlier. But that was not the end of it. Galileo moved along in these experiments and added more sort of depth to his experiments by doing the following. Okay? He also noticed then that when he uh, inclined planes in such a way that an object would roll down this inclined plane, and at the end of the inclined plane, if he placed another incline, okay, then when the object rolled down the inclined plane, what would happen?
Sir?
Yeah.
Who?
Go ahead.
Okay, sir, it actually depends. So if the part where it's straight, if that's for too long, then it'll just stop where the second incline begins. But if this is short, then it'll climb up and then climb down.
Short or made sufficiently smooth. So if you remember last time, I had said that he used the best workman that is possible. He himself was an excellent metal worker and woodworker apparently. So he made the equipment smooth, sufficiently smooth, in such a way that the ball would roll and more or less go with uniform speed on that part, the flat part. Then what will happen?
So,
Yeah.
also depends on the weight of the ball.
Why does it weight of the ball?
If it's a very light ball, like it's hollow, then
Okay.
it'll not have the same.
It was not a very light ball. These were made of smooth metallic surfaces, or I think he used smooth wooden surfaces. But you are going back to Aristotelian thinking when you say that it depends on the weight. Because what did
No,
the
I don't mean it like that. Like if you compare it like with a basketball, and if you use a ping pong ball, then there's obviously a difference in how it will.
the materials are completely different, you see.
But then that doesn't depend on the weight. That might depend on other factors.
Okay.
So that is what I'm trying to say, that if he used a metal ball and a metal or wooden ball, smooth surfaces, and he rolled it down, and he kept this part short. So it is not like represented in scale over here. So this is not to scale. Right? Then what will be the simplest thing that you can expect for it to happen?
Sir.
You would roll up this inclined plane, yes? So
Yeah, it would.
ball reaches here, it will gain some speed. Assuming that it will maintain that speed more or less as it rolled over here, it would start rolling up with the same speed. Now the question is, it will go up the second inclined plane at the far end. Question is, how far would it go up? Yes,
Height as
Shiv.
Yeah, so like, yeah, I think it would go half the ramp and come back.
Why half?
Because it doesn't have that much energy to go upper.
What is that new animal energy?
Sir,
That it doesn't have that much speed. Yeah.
Okay. So by making the surfaces smoother and smoother and as smooth as possible, he found out that he could make the ball go up almost to the same height as before. Okay. After which, of course, the object would roll back and something would happen. But we are not interested in that part. We are interested in the height that it reaches. Yes.
But I have a question. Sir, I have a question.
Yeah.
So if it goes there, would there be a pendulum effect? Like, wouldn't it be
Yes, there would be a kind of pendulum effect. So you can see his investigations into pendulums, his investigations into falling objects, his investigations with inclined planes. All of these are coming together, are coalescing together. Okay. So is this point clear that if you make the surfaces sufficiently smooth and you conducted the experiment carefully enough, then you could make the ball go up as close as possible to its initial point before, of course, it will roll down. Do you see that point? Is that clear or not?
so? But I have another question.
Yeah.
So what if you decrease? Sorry, what if you decrease the incline? Like you make it a little more straight. Then what will happen?
Okay, that's a very good question. Are you talking about this incline or this incline?
The B incline.
Sorry?
The B incline. The B degrees.
Exactly. So that is where the question comes in. So if you change the incline of this one, so forget about this part. I'll put the B over here. And then he changed it to, let's say, B1. Then what would you see?
Would go a little higher.
Why would it go higher?
Because
So there will be less gravity.
Why is there less gravity and what is gravity?
Hey, what is that animal?
okay, we have to travel more distance. Plus, you have the degree is lesser, so it kind of equalizes, right? So it should travel the same distance.
Yeah, so it's an observational thing. That the angle that this inclined plane B1 to this horizontal. So this angle and this angle, if we are comparing, the angle of B1 and the angle of B, angle of B1 is lesser. Okay, so and assuming that the ball, the surfaces are smooth, etc., etc., the ball will again nearly go to the same height before it starts coming down. Okay. Now, what if he reduces, going along with the same question, if he reduces the angle even further? Okay. Presumably, the same thing would happen. It will go a little bit lower down. But notice that in each case, the distance that the ball travels, therefore, overall, from let's say this point up to the end point, is higher. It keeps increasing. Do you notice that?
So the distance increases.
Yeah.
Repeat.
Are you having any difficulty understanding this? Okay. So if you are not, if you
Sir,
are,
can you explain it once again?
sorry.
Can you explain it once again?
You understand the whole demonstration, right? The detail of it is that
Yeah, so
when you keep reducing,
you reduce the incline
yeah, then one
and
it travels further.
okay.
But the second point, which is a little more difficult to see, is that Galileo concluded that the ball which rolls on this flat part because of the drop that it gained over here, it will attempt to reach the same height again. That's a little anthropocentric, which means that you kind of try to give human qualities to an object, which is not quite correct in science, which is to be avoided.
Personification.
But the ball has a tendency to try to reach the same height from which it was released. Will you agree with that or not?
No.
Yeah.
Yeah? But
Yeah.
in attempting to do so, it also travels a greater distance depending upon the reduction in the slope. Correct? Yeah?
Yeah.
Okay. So here there is a very important change in the strategy of experimenting. Obviously, if you make the inclined plane lesser and lesser sloped, right, then the distance of the inclined plane also keeps increasing. And there is a certain limit, because every time you increase the length, the ball will travel less closer to the original height from which it was released. Here, Galileo made a second big contribution to science. And that contribution was what is known, generally we call it like this, is called a thought experiment. Have you heard of this term?
Yeah.
You have heard of it before. So
Yes, sir.
basically, where it is not possible for us to do an actual physical experiment, it is valid as long as you hold certain conditions to be true to conduct the experiment in thought. Okay, so Galileo imagined something like this. He said, uh, if the inclined plane were sufficiently smooth, okay, but completely flat, like this. If you roll down a ball such that it gains a certain speed, then the ball will continue along this long inclined plane, the smooth part of it, and strictly speaking, since the ball is attempting to reach the same height at which it was released, it will never reach that height because this part is completely flat. And in attempting to reach that height, the old height where it was released from, it will continue to move infinitely long distances.
Sir, but it will eventually come to a stop, right?
Yes, and that is the important thing over here. What
So,
prevents that from happening? So Galileo turned the question. The reality of it is, if we create something like this, then the ball at some point of time will stop. But the reason it stops is interesting. The reason it stops cannot be, right, that it wants to stop. It does not want to stop. It wants to find its old previous height. So it travels looking for that previous height, but it stops because something makes it to stop.
Yes, sir.
You get this?
So,
Yeah.
so,
Yeah. Ask your
so
question.
can you repeat? So can you repeat what you just said right now? I didn't understand the.
Yeah, sure.
what you were
Basically,
talking
it's
about.
forced to stop.
By a thing.
Exactly.
Sir, maybe it's just our thought which thinks that the ball wants to go to its original height. I mean, there's no way we can.
so it's like if nothing stops, you keep moving.
Yes, that is the interesting.
It's like traveling in
Galileo.
space.
That is the interesting
Galileo.
that he came to. that there must be something that stops it.
So
That is why it stops. Otherwise, it should not want to stop.
An external force.
that's what happens in space, right?
We all know that.
Yeah. But the thing is that he did not come to the end conclusion. So, in the sense that he recognized what the elements were that were playing over here. And when I say elements, I don't, okay, let me not use the word elements, let me say factors. That there were factors which are at play, which is the reason why the ball comes to rest. Okay? And this is a very important thought experiment to be conducted, because in those days, natural philosophers were stuck with a particular question. It was like a chicken and egg question. What is the natural state of any object? Okay, so the answer, of course, is rest or motion. Right. So Aristotelian thinking suggested that the correct answer is rest. Why? Because you do not see objects moving unless something causes it to move. Right. So motion cannot be the correct answer. If you think even logically, you look at objects around you, you will say that yeah, unless you move it, no object will be at rest. But Galileo's experiment turned the whole thing around. It simply said that objects are at rest because something made it come to rest. If the object were set in motion, then unless something acts on it, it will not come to rest. It will keep moving.
Sir,
Yeah.
sir, I didn't understand the thought experiment. Can you just repeat it once again?
Okay, so the thought experiment was that knowing that objects which are rolling on a smooth surface would attempt to reach the same height from which it was released, and it would travel greater and greater distances to achieve the same height. If you flattened out the inclined plane like this and made it infinitely long and infinitely smooth. Okay, so I'm adding that. That is why it was a thought experiment. You see, because you cannot make an infinitely long inclined plane, you cannot make an infinitely smooth inclined plane. But what if you did? He asked that critical question. So, infinitely smooth and infinitely long, then there is no reason why the object will come to rest. It will keep moving, trying to find out where is the place where I can attain the same old height as before. Okay? But reality is that it does come to rest. So he answered this question by doing the thought experiment by saying that if the object were in motion, then it will come to rest only because something prevents it from moving. If there is nothing to prevent it from moving, which means that it is infinitely smooth, then it will continue to move infinitely long distances.
Okay, sir.
Okay? So,
Yeah.
by conducting this experiment, Galileo put probably the last nail in the Aristotelian thinking coffin, right? By bringing the whole thing back into a question. Because at that point of time, people were more or less convinced that rest was the natural state of objects. Whereas Galileo said, no, it is not rest, it could be motion, because an object at motion will come to rest only because there is a force acting on it. And if there is a force acting on it, if there is something making it do that, the notion of force hadn't come about till then the object's natural state cannot be of rest.
Sir,
Yeah.
so if I drop a ball down an inclined plane from a very high point,
Yeah.
suppose from the Leaning Tower of Pisa, I drop it down an inclined plane,
Yeah.
and then it should climb back to this thing, right? Like if I add another inclined plane next to it. then it should go back to the Leaning Tower of Pisa. But that's not very common if you say it.
That is not very.
It's not going to reach that point. It's going to eventually roll down.
Yes. So basically, what happened as a result of this is that unknown to him. So it's not as if he realized it at that point of time. What he ended up doing was that he said that there might not be actually much of a difference between what happens on Earth and what happens in the heavens. So the sublunary and the superlunary distinction that was Aristotelian at that point of time, that notion itself got questioned. Okay, and although he did not give this particular word to it, the idea that the reason why this ball would attempt to maintain its state of motion is because of some quality contained in the object itself. Therefore, all objects have to contain the same property or the same quality. That quality came to be called as inertia. Okay, so inertia is the state or the property of an object because of which it will continue in its state of motion unless some external factor would cause it to slow down and come to a rest. If there were no external factors, then an object which is set in motion should, because of its inertia, move continuously.
Can you repeat the definition?
So it's not really a definition. You can always look up the definition, understand the essence of it. The essence of it is that an object which is set in motion will continue to move unless something causes it to stop moving. If you can appreciate.
That is that object's inertia.
So wait,
Yeah.
that's the natural state of objects, inertia.
No,
It's just a property's name.
it's a property's name. You give it a name. If you don't like it, you can call it whatever you like, but it's just so that historically it came to be called inertia.
No, like what is like it's a property that things possess.
Correct. And in the following classes, we will see what that property is related to, but we will come to that a little bit later. For the time being, if you can appreciate the thought experiment, the transcending. So he kind of moved from looking at experiments in terms of what can be achieved, in terms of workmanship and so on, in terms of equipment and so on, to move from something that is grounded, earthy, possible, mechanical, to something that is in the imaginary plane. So only by going imaginary plane with some rules that he was able to achieve that breakthrough in thinking. Yes.
Sir, don't you think this inertia ka concept is very debatable?
Of course, it is debatable, and that is the reason he himself could not formulate this particular concept very well. He left
Why
it.
do we still So then why didn't they debate it at that time when this idea was newly
Of course,
thing?
it was debated. But the debate had to wait a little bit until the coming of the next big mind, whose work is what we are going to go into. This
Newton.
inertia was actually given by Newton. This was Newton's concept. So Newton, in a way, put together
Stole Galileo.
these ideas, the developments made by Copernicus, Kepler, and Galileo, and then he synthesized a new idea of motion, which was put in his book, Principia Mathematica, and that book and its contents is basically what we will study in the rest of the course. So this brings us to the door of Newtonian synthesis.
Wow.